guys. So people, it's a bad hour to start with, like after lunch, and then it's good. So let's keep it interactive. So these are the learnings which we have done through when we are scaling sessions for Flipkart. So there might be mistakes, and then there are different opinions. We can rise them out. And I'll go through the journey of how things are happening for Flipkart sessions and stuff like that. So pretty much, so let's get started with it. So I'll be discussing majorly around the thoughts and trade-offs which we did for different levels of places for scaling the sessions. So to introduce about Flipkart sessions is this one. So Flipkart doesn't maintain sessions only for the logged in users. We maintain sessions for anybody who touched flipkart.com anywhere in the internet. So even if you have touched any blog which contains a Flipkart banner, you'll be treated as your session starts there. And that session goes on till 1 month kind of time. If you reach any time against Flipkart, we will tell you this is the product which you have viewed long back, and then those kinds of history, and then details is being done. So the other major feature why sessions and then guest checkout becomes an important part of the sessions, basically guest checkout, with Flipkart's guest checkout, you don't need a login. So you can buy anything without giving a password or anything, and then authentication and stuff like that, you go there. So, and also we had the cash on delivery functionality where the procurement goes and procures before you pay. So there is a large amount of stuff. People can game the system, say place a lot of orders and then in COD mode and stuff like that. And if a person catches hold of somebody's session, so we have saved card feature, your credit card gets saved with Flipkart account. So they'll be able to log in as you and then do purchases for them. So that's why the security and then scalability becomes a more important part. Scalability becomes an important part because we don't have a remember me button or something. If you logged into Flipkart for 1 month, you are already remembered. If you log in again, it extends from the last access to another 1 month kind of stuff. That's what. So we have aggressive goals on that. We wanted to increase that 1 month to 3 months now. We are working on. So we started with 1 day, then 1 week, and then we reached to 1 month kind of things now. So that's the difference about sessions. And let me tell about so what all things which sessions supposed to handle is different. Generally, sessions handles your login and logout states and remembers some point of the user state, whether you have selected some options and stuff like that. And most critical during your transaction, when you do checkout, when you're trying to buy something, and then the flow is maintained in the session. So these are general things which we do. And Flipkart, in addition to that, we do track a lot of things other than that, your recommendations is based on sessions, because a non-logged in user is an anonymous user. Is it audible on the last? Yeah. So basically, a non-logged in user, you have to keep his anonymity intact and as well as to maintain his whole history and then do recommendations and things like that, upsell. So a lot of things needed from the sessions to support that, because you don't have the user's information around other than other places. So the other things is basic thing is scalability and high availability of sessions is important. So if session goes down, the entire thing, you cannot do much operations around the site. So basically the transaction operations. And we wanted to do, other thing which we want to do is with the sessions, a lot of other subsystems tracking, email marketing, and all these people wanted to get data about the sessions so that they can do better things to the user. So if you're on a low bandwidth sessions, we will try to figure out and say reduce the AJAX calls and see what is the minimal information you can do. Those kinds of information you can do. And different kinds of subsystems will use this sessions info to do that. So that will be the major concerns around. So let me give you I think the image is not very visible here. So design summary of sessions, what are the concepts which we want to handle in terms of sessions? We want to keep the key separate. So client key, whenever you have a sessions, we need to send out a cookie or something to identify that this is your session and this is a session ID kind of thing. So we wanted to keep that little bit, the ID generation part as a separate module, so that along with the ID, we can do a lot of more things so that it becomes more secure and then useful. Then we have the session functionality management. Flipkart side, we wanted to keep the sessions in a generic format so that Flipkart internal users also use the session, external users also use the session, and then sellers. So different parts of users will use the similar kind of sessions. And also what we have is the session info store, we wanted to keep it separate. Any subsystem which wants to use or store some data associated with the session, they should use the session substore kind of stuff. So that is what the session info is handling about. And we said we will create a storage management separate from all these concerns. So storage management needs to be a separate concern without any business logic involved to it. So that's the whole idea about the sessions. So let us look at individual concerns we were trying to solve at different point in time. So security concerns, like I said, sessions is in Flipkart contains all the user-sensitive information, and then session hijacking is a bigger threat because you have cart and other things. And you have, people can try and tap your request at some point in time and do a replay attack. So we have other things like the mobile request and stuff like that, where the JS is not there or the cookies is not there. You have to do everything through requests. So people can catch that request and then replay and then create issues and try to use, take your data and stuff like that. So, and the other major problem is like creating large number of unwanted sessions, like DDoS attack kind of stuff. The store has to store it, like because we are storing it for a month. Anybody creating, any crawler or something creates sessions on our site because they can even load. Like one day, we had around like 3 crore sessions created by a crawler. So those kinds of issues can crop up. So that's the kind of practical issues which we are trying to solve by this ID generation as a concept. Like, so use an ID plus verification info as a part of the session cookie, so that you don't just rely on the random ID alone. You have other information so that you can do safety and security around that. So basically the verification information may be the information which we created from our side, authentication information and the other stuff. And the other one is like, we wanted to make sure that your session ID is encoded with a safe key kind of stuff, rather than anybody should not be able to construct the session back and then replay it kind of thing. So it has an encode and decode kind of scenario. So keep your keys so safer. So basically we want to have multiple keys. We should not have a single pattern so that people are easy to identify. Like the first 4 characters is this, next 4 characters is date, the next 4 characters. Those kinds of things should not happen. And also we should make sure that every information which we provide is secure. So we have been implementing security key kind of schemes. So basically we had multiple schemes of public key and private key encoding to avoid this issue. So the kind of verification information which we are looking at is around, so we used login and log out, those kinds of secure pages wherever it is necessary. So basically your session cookie setting, when you are trying to do it in a login related cookie setting, try to make sure that it's a HTTPS cookie so that you are safe on the other side, like you don't get replay attacks on the server. And what we did, other thing was like client fingerprinting. So we want to identify a client because you are not logged in and we need to still maintain a session for you. We wanted to identify a user, like say this, how will you then say that this cookie is not copied by somebody else? Like, so what we wanted to do, client fingerprinting. In the client fingerprinting, you can go to different levels. One is like, you can have the IP address, browser, and also the device information kind of stuff. So when somebody tries to copy a cookie from one device to other device, you will be able to make sure that this is breached. So create a new session for the user rather than allowing him to access the existing session kind of stuff. So that gives you a flexibility. In the client fingerprinting, you have different levels. So right now we use around browser as well as a little bit of the IP scheme. So basically we found that people's IP change when they go from home to office and office to home kind of stuff. So what we do is like city level IP checks we do. When you change from one city to other city, you usually gets logged out kind of stuff. So that is for the security concerns kind of stuff. And the other thing which we wanted to do was like, make sure any cookie which is sent by us, it's a very simple option, but it makes it more harder for the hackers to do. HTTP only cookies, like your cookies cannot be fiddled with by JS or widgets, or somebody cannot take your cookie and then post it to some other place kind of stuff. So, and the other ones is like, major thing is around like the checkout pieces, like the form key and the other one time and count based expiry tokens. Like basically in sessions, we introduced form keys and then time-based counter tokens, so that on the secure pages, like when you are in a My Account page or a wallet page kind of stuff, there we have counters and then retries with form keys. And the session also contains a timestamp. So any user who is trying to come after 5 minutes, it's okay to ask them for a password again, because it's a page where you have money involved in it. So those kinds of implementations helps us in this. And all these information we have encoded into the cookie information, which we send on every request kind of stuff, so that these formats are decoded and then we are safe on the other side. So I think let's let's move on to the next level. So the other major concern for the session system is like availability. Can your session be off for a few seconds? Like it's not possible for us to keep any session off for a few seconds. And the other thing is like, what if your server which is running the session service crashes? How safe are you from it, and then stuff like that. So that's the important factor. So if one of the web server goes down for some reason, like the hardware issue, and you don't want all your users of the particular web server to be logged out, like you want them to be in the same state what they are doing. Like, so loss of session is like loss of customer at any point in time. So we wanted to build the session service as a distributed service. Basically, we wanted to say like wherever the web server is running, we will try to put one session service over there running, so that you don't have a single failure kind of stuff. If the server fails, it's like the web server also fails kind of stuff. So you get it. So this introduces a lot of other issues also. You have data consistency issues coming in because there are n web servers, and then each one has a session service running, and then your request is load balanced. Like it can go to any web server kind of stuff. So you will get into issues like data inconsistency. So we used versioning everywhere. So the session which you write should be the same session you have seen before the request. So then only you are allowed to modify. Otherwise, you have to do a retry and merge the data. So the other thing which we want to do is like, what if the session service crashes? Like we wanted to say like the session data needs to be separate from the service. Service is supposed to be stateless. Then only you will be say, your crash of a service doesn't mean you lose data. So session service, if it crashes, the data is safe from some other place. So we said like we will go with a centralized data store. And so we will also say like we have a hard standby or 2 working copies of any data store which you choose. Whether it is MySQL, Memcache, you should have 2 copies of it to make sure that you don't lose sessions when it is running. So because in sessions is like what we are fiddling with is a live user. If your session data is lost, you will be losing the customer. So this is a kind of deployment architecture which we had for the session. So every web server, the session service is running, and then we have a primary data store and the data store replica, where all these session services will have a backup connection. If your primary store goes down, you get data from the secondary one. And we have an analytics data store where people want to do offline analysis of the session data. They should be doing that from there. So on this, like why we wanted to keep the code separate from the web servers is this one. Like the session service, we want to keep it separate so that you can deploy the session service on any kind of web service. So it doesn't need to be just the Flipkart.com. It can be any other site which is running. We can do that. And also we have the mobile sites doing a session handling separately on their own kind of stuff. So for that reason, we want to keep it separate, but it is better to keep it on the web servers end. You get the other flexibility is like the data transfer is less, you have modifications, and you also need your code to access a lot of session information. So if you keep it as a remote service, if you want to fiddle with any one variable, you need to do a remote call. That will be very taxing. So it's better to keep them at the same server. Maybe use an IPC kind of stuff. So this is a larger challenge of the whole session service. Like we had 2 million sessions getting created every day, and then we have concurrency of 1,000 users acting on Flipkart site at any point in time. And because we were persisting for 1 month, we have 60 million active sessions, like users whose data is there with us. And then, so every user who comes to Flipkart in general acts around for a 30-minute window. They does 10 or 20 operations in a 30-minute window kind of stuff. So this is a key point in like why we are putting it here is like it's one of the requirements helped us to design the data store the way we have defined it. So and what we have is like the information which we store about the user is around 20 KB. So you might be wondering what the 20 KB holds on. Like it holds on your like account on the cart which you have, things which you have browsed on the last few hours, to the information like your past orders, what all the products you have looked at, and all this information is there, so that the recommendations and the other systems will work on that. So so the data change rate on the sessions right now is like every 3 requests you do some operation which will change the data on the sessions. Like you might browse a product, you need to add that information to the session data. And we are pretty sure like loss of data means loss of customer. You cannot be affordable to lose any one of the data at any point in time. You should not lose the data. So these were the concerns which we are trying to address on the overall place. So 60 million sessions is like into 20 KB, it approximately goes around to a few hundred GBs of data stored. So any caching solutions will not grow up to that volume which you are looking for, 500 GB of data. So we said like we'll do an in-memory caching and asynchronous write to the persistent storage. So because full thing on a key value store is not possible. We want to store 60 million sessions, which is 500 GB of data. We will not be able to store that full thing on in any in-memory storage. Like then what will happen is like if you want to grow three-month sessions, like then you have to create that many servers which is using RAM, and then most of the data will be active users is only few thousand, like in a day. You have 2 million users active on a day, and then you have 60 million users data on memory. That is like waste of resources on that side. So we'll be doing a selective amount of caching on the in-memory data stores, like memcache and stuff like that. And then we will do a time-based buckets, like to reduce lookup and delay on the persistence layer. So we want to be sure of like in any data store, like which you say like of 60 million size, if you want to index and create a B tree and then search on it, it will be slower. So what we said is like we'll do little bit around time-based bucketing. So you look up only the data which you have accessed on the last minute. So your session, let's assume that you accessed Flipkart 1 month back. We know the date and time from the cookie. So we'll be able to detect you are in which bucket of the data and go and pick it up from there. And what we also did is like we had crawlers, and then like usually price scrapping sites and all these things will be there. We want to differentiate them from the actual users. So basic way is like we did a data version and used it before the persistence. So basically crawlers, when they come, like they usually don't come with the persistent cookies. Every time they don't persist and then do a crawling. Like in general, they come and hit without a cookie and then get a session data. So what in the data versions, we said we will be not persisting the guy who don't have a version increase kind of stuff. He just gets the first data, empty data. You don't persist him. And we also wanted to do a trade-off on the replicas we maintain for a longer time. So how many copies of the data you want to maintain. So for an active user, you need to maintain at least 2 copies, like so that if one fails, you have the action data, like it's not lost. For all the non-active copies also, you keep 2 copies, but on a different kind of storage. Maybe on a HBase and Hadoop kind of, like high latency storages, you can have them. So we said like we wanted to pull out the storage layer separately and then build that storage layer as this one. So what we have is like the bucket management, which takes care of your hourly bucketing or daily bucketing kind of stuff. And then you have the live users data majorly coming from the Couchbase. And so we will have a data sync queue, which will be replicating the data into the MySQL kind of stuff. In the MySQL will be a hugely partitioned tables, like a bunch of tables which is partitioned every hour kind of stuff. And we also have sharding across the multiple MySQL servers. And we will also put, once after the aftermath, like long data, we can push it into HBase and then do an MapReduce kind of analytics later point in time when you want to do. So the async data migration can happen once in a day kind of stuff, like archiving the data kind of scenario. So the other thing is like how and read and write happens between the cache and the DB. So basically when a user comes for the first time, so if he's a user which is active now, his data will be available in the cache and then he'll get that in the cache. So what if a user comes after a month kind of stuff, like whether you don't have an active bucket kind of scenario. So once a user accesses something, we need to write that information, like you accessed which page, which product. So we will write it back, and then the write goes through an async write into the DB straight away. The async write will have different kinds of priority depending on the information. If you add something to the cart, we will write it immediately. If you have browsed something, we'll have a 1-minute window to batch it up and then write it kind of scenario. So what happens if a user comes after a long time? So we know his bucket, like he'll be 5 hours behind the schedule or 5 days back. So based on the bucket, you will decide on which DB bucket he's going to be present, and then you'll fetch from the DB and start serving the page. Once you have served the page, like you will need to again write the information about them back to the case. So what we'll do is like after we get the data, we write them to the cache, so that after that this user becomes an active user, and we do an async delete of the data which is present there. So because this data, nobody should be able to replay the same cookie again, a cookie which is captured 5 days back. Like if you accessed it once, the whole cookie changes and then your data is on the other bucket. So next time if somebody tries to replay the same cookie, they will not find that in the same bucket. So it will go to the active bucket, and then we'll have writing back to the active bucket. So usually you will get all your active users into the active bucket, and majorly they will be coming from cache. So you will be having a 90 to 95% of cache hit ratio, depending on the reads. on the user. So this is another flexibility part which we want to build on that, the data storage needed for different subsystems. So the kind of subsystems which we are talking about is like shopping cart, recommendations, browse, search, order history, and personalization information. And it starts from there and it goes on further by the other set of subsystems which we are talking about. So these are not conventional subsystems which have to store data into sessions. Like these are not mandatory data that session has to hold. Session needs authentication information. Session needs what user you are and what is your current activity happening. But these are the other subsystems data which we need to have it because of the reason being like to support guest users, this information is not stored anywhere else. Like you need to the guest user has only one identity, that is your session ID in the whole system. So you have to store it against sessions. And then we wanted that flexibility. That's why, because 60% of our users is like guest users in general. Like Flipkart has a different scenario. Like once we started getting guest users, we thought it will be 10, 20%, and then actually we are surprised by the numbers. And then we have to build this store for them. And what we wanted to do with them is like every subsystem, what kind of data they are storing. If we have to start instrumenting sessions to do all this data, management of it, then session becomes a one big mammoth code. Like every subsystem, if they want to change any logic of what the data needs to be stored, they need to come and change the code in the session service, which we don't want to do. So what we said is like, we will provide hooks to your events. Like whenever an event happening, you create your data as a class, and then you have your own hooks and service calls which needs to be made when something is changed. And you return back me the data which I have to store back in the session. So we were publishing the events like login, logout, and all these different kind of action, browsing, and any action will be passed, and you will get a hook to it. And we will say like, when we said like this happens, like the systems like cart and all will have a lesser collision, but recommendations will have huge collisions because people can open multiple things in multiple tabs. So you will have Ajax calls, and then you will see people flipping from pages to pages. So you'll get collisions on the same data. You want to write one data, add a product to the session. While doing that, you will get another request to add again a product. Like you should not miss both the updates. So what we do is like whenever we get a collision, we send back another event saying like the collision occurred on your data to update. You keep your version, and for every subsystems data, we maintain versions internally separately. So whatever because these systems are distributed, they don't know about one guy writing about the other guy. Like we don't lock the tables. Like locking, we don't do, because if you start locking, at a time a user can do only one activity on your session. Like it's not only the users who is going to access your sessions, it's your backend systems will also access your sessions. Like if a recommendation wants to recommend something for your next page, what they do is like we fire an event, this user has come in new, you start computing the recommendations now, and from that point onwards, like when you come back to the second request, we show a recommendation based on your past history. So this is how the things happen. So this backend systems will also need to access your sessions, so you cannot have locking. Locking is a major contention you will have whenever you scale to the system. So collision, and we used to do like versioning and then remove that action kind of stuff. So these are the solutions which we have been providing around that stuff. And then the other thing which we did was like keeping our system very clean. Like the session store will contain only 4 columns majorly. It's like ID, user ID, status, and then timestamp kind of stuff. And a big blob of JSON which will contain all the subsystems data. So that whenever a subsystem changes its data structure or something, you don't need to change anything on the schema. Schema level changes are hard to deploy on a running system which has 5,000 QPS at any point in time. So that will help us on the JSON store, which will help us doing all this stuff. So avoiding the collision. So the other thing which we want to do is like once we exposed out these APIs, a lot of people started using session store as their base store. So we need to ask certain questions about, is this session only data? Is session the right place to store this data? Is it data related to an user? Like order history and stuff like that, people started storing in sessions like that for faster access, but they are not the place to store all these data. Like and also we need to make sure that your session store cannot go beyond a certain size. Like you have to be cognizant of it. So if you start storing browsing history for the entire month, one user might get into like MBs kind of stuff. Like that will not scale. So you have to also ask about the refresh rate. So if you are adding anything like, so basic thing is like when we started adding the recommendation info or the browse history info, every request there is a write. Earlier when you have shopping cart, if you have 5 requests, one might be the add to cart, and then you'll have one write to the data. So you'll get refresh rate. And then what is the criticality of the data being persisted on a persistent store? So whenever crash happens, what kind of data needs to be recovered? Like, so basically, if somebody is doing a checkout and his state is being stored over there, that needs to be persisted. That transaction has a criticality of high criticality. But if you lose a browsing history update, you can just get it back from the logs, or you can do it little asynchronous kind of stuff. So all these questions we need to ask, and then make sure that people, which are first thing you need to be make sure it's the right place to store it in session. If it is not, don't allow the people to add it. And don't allow any subsystem to add data without a size restriction on it. And always try to make sure like the refresh rate is the right rate which we have set in. So now we'll go to the design of the, so what we are building next for it, like next level of scaling and then currently working on. So what we are planning for is like when we come up with multiple data centers, people will be moving around from data center to data center. Like how will we make sure that sessions can be migrated from the one data center to other data center kind of scenario. So what we had is like from the ID detection place itself, we will have a data center detection module which will tell which data center this session belongs to. So let's say we have one data center in Mumbai and one data center in Chennai. So the people are divided across based on the geo IPs. So you will have different users going to different sessions. So we will see like whenever the data center is detected, if it is a local one, we will go to the local session service and fetch the data. If it is from a other data center, we will ask for a migration of the data. So move this user from that data center to this data center. Like if a person flies from Bangalore to Bombay and he has to be changed to the Bombay data center from Chennai, we need to go through the migration of the data center. And what if the Chennai data center completely goes down? This data center 2 is not at all available. What happens to the data? So for 50% of users, what will be coming is like the fetch data from the inactive DC copy. So inactive DC copy is something which will not be in the cache. It will be on the storage layer. We will be doing that sync through MySQL and HDFS sync kind of data. So we will be working on a pipe which will be syncing data at a continuous scale. So that will be the data which we'll be fetching from. So that will be an inactive copy. We will not use it for writes and reads. When one DC goes away, all the DC's user will be migrated to that user, and then we'll start fetching from the inactive copy and making them active on the session service. So this is our future request. And lastly, to summarize, like do's and don'ts on a different levels of session data, which we had learned over the time. So basically, don't run any query on non-primary key in a live session DB. So if your session data store has something, don't allow anybody to code any query which works on any field other than the primary key. So if you allow them to do, there was a place like when we said like we wanted to write one guy wanted to write a monitoring script saying like every 1 hour how many sessions are getting created. Like he did a group by query on sessions. Like so every 1 hour there will be slow queries happening on the session service. Like instead of it taking 30 ms, it will take 50 ms. So we analyzed why that is happening. That is because like the guy was doing a group by on a non-primary key. And this happened once when somebody said sessions are slow. One guy wanted to run count star and see how many sessions are in the session table. The table was at that point in time 6 crore size. He ran it and then it even blocked the whole data. It created more trouble for the person. Like these are the small things which we need to make sure. And take care of the data sizes before you update. Like earlier we had a session blob size is 250 KB kind of stuff. The session data exceeded more than 250 KB. We did not take care of it. People wrote it and then their sessions broke. So that is the kind of learning. And whenever you touch the ID scheme, like how do you generate the session ID cookie? If you change it, always make sure that you have backward compatible code. Otherwise, you will be logging out the users whom you are not supposed to be logging out. So that's one of the learnings. And the other things like the different kinds of sync queues which we are building, try to make them based on the data priority. Otherwise, your data will not catch up. So this is a classical scenario happening. Like you have 6 crore sessions happening, and then your data lags for 1 hour. And then if you don't know what queue is critical, what is not critical update, the second database, like the slave catching up becomes too harder problem. It takes 8 hours to catch up. For that 8 hours, if the master goes down, you don't have any other data source because you might have a data loss. So always make sure that is there. And whenever we are deciding on the partition sizes, so basically you want to do one hour bucketing or 1 day bucketing, it depends on your data size. So MySQL has this, whenever you have a data store or something, your lookups has to be simple. So if you have only few thousand sessions per hour, you keep it in an hour. Like if you have few lakh sessions per hour, then you have to go to a granularity which is less than an hour. So if you have only few thousands a day, if you keep it on a hour, you will create tables which will have only few hundred rows. You don't need to do that. Like, and your table scan will take more time. Like you need to decide on which table or which bucket you are going into. That bucket sizes will increase. Lookup on the buckets itself will cost you more. And the other simple thing is like, don't try to complicate your ID generation logic. So because this is a place where people can do mistakes and then it can backfire you very well. And basically those are the questions. Like, so these are the kinds of things which we have learned, and now the floor is open for questions. And I'll suggest you my solutions of whatever we have tried in the past and what worked and what not worked kind of scenario. I think, guys, do you have a mic? Yeah. Yeah. So no, actually what we did is a version number, like a guy who comes in. So any user for the first time when he comes in, okay. So we'll create an empty session for him and then put that version number as 0. The crawlers will always get the session as like version 0. Version 01 doesn't need to be persisted. Actually, when the person comes as a second request, like the AJAX request or the callback comes back, crawlers never do a callback.
But you're still creating the session, right?
No, we create the session only in the cache layer. We won't persist it.
But I'm just saying, I mean, it's a hypothetical question because it's similar to a DDoS, right? So they can still be creating millions of sessions. Although it's not persisting, it's still in your memory.
But only thing is like it is created in the cache layer, memcache layer, where you can afford to have that one. And also what you do is like graylist the IPs. Once an IP starts creating too many 0-numbered sessions, you have a map. Like once the number of sessions per IP goes beyond a certain 1,000 limit or so, you block the IPs. There are other solutions to it. In the session service, we are making sure that we are not storing it or persisting it so that our backend data is always clean. The data which is on the persisted data store like MySQL or HBase is always clean.
Yeah, because the problem with IPs is also because
the ISPs are coming. Certain ISPs in India have like huge number of things. So we need to do that. There are other ways to do it. Like sessions is not the only place to solve it. We have other callbacks, AJAX callbacks, and you say like you put a text box. If the same IP coming again and again, don't show any page. You put a text box saying like if you are a manual user, type it. Once that response comes in, then start responding to that IP. Otherwise, don't do that. So the other thing is like what we have figured out. Another problem is like when you start blocking one user. Like there was a guy from IIIT Hyderabad was calling. We blocked their IP. The whole campus did not see Flipkart.com for half an hour. So the gray listing. So then we learned that we should not do that. We should not block it just on an IP. So first time when they come and do this fingerprinting kind of stuff, once they have it, their cookie, only with IP we say like, this IP is gray listed. Only if the cookie comes back to us, we respond to the user. Otherwise, we don't respond to the user. If it's a crawler, he'll not send back proper cookies. Like,
but technically, what you're saying is, in case if there is all new users coming in, they will also kind of get.
No, the first time they will get a pop-up box saying like you type in this. Once they type in, we set a cookie.
So you have like sort of a captcha, like
gambling we should
and
do.
all these people try to solve.
So basically, callbacks will help you decide that.
And in terms of sessions, so you're no longer using sticky sessions. So you have a central.
No, we have a sticky sessions to the web server. But
what if the web server goes down?
No, but the data storage is separated because the storage data is there on the central store.
So it's just a web server sticky session.
Yeah. Web servers is stateless. Even though you have sticky on the web servers, web server is not a stateful one. So your entire state is on the session store. So if the web server goes down, all the users will be routed to other web servers. They'll get the same data. So that cannot be done when you have a multiple DC scenario because the data has to be brought from the other DC. That's why we are working on the different solution.
Yeah, but then I don't see. I mean, I was trying to understand why you're trying to have a multi-DC thing because, I worked on 2 different startups where once I was trying to do with Amazon's.
So basic thing is like an IP pinging from Bangalore to Bombay is like you have a time delay. Like if your server is closer to your location, you have faster response times and you can scale much better. You will also have a disaster.
But are you talking about the same user, the single user who's moving? Let's say I took a
flight.
No,
single user will not move day in and day out. That's not a regular activity. Only when you want to switch the data center, you want to move this data center down for a maintenance or something, you need to switch. Or other case which will be happening is like if Airtel's link to Bombay and Chennai is down, it will start routing everybody to the Mumbai gateway. Okay, so there are different places of failures. Like if ISP fails and they'll not be able to connect to this ISP, they'll start routing it through VSNL. So we have seen Indian IPs going to Singapore and coming back, like if the link is not there. So those kinds of cases, you might see a large migration happening.
These are challenges very specific to, unfortunately, very specific.
Yeah, it's specific to scale. We did not have the challenge 2 years back. We are having it now. So we are still working on solution in a reliable way. So we are testing it out right now.
So what is a session? Sorry for asking so many questions.
Yeah.
I specifically came for this
okay.
talk for that. How are you storing the sessions right now? On like what are you using Memcache for caching?
So basically we use Memcache we used before, and then Couchbase gives us a reliability on the data replication kind of stuff. We did a custom Memcache replication before, and Couchbase gives you by free all this stuff. So we are using Couchbase right now to store the active data for the current 3 hours users. Last 3 hours users will be on the Couchbase. Rest will be in the MySQL in a hard partition kind of scenario. And even larger history data will be pushed to the HBase kind of scenario.
Thanks.
Yeah. Yeah. So guys, one last question. I think it's... Thank you guys.